Thrashing occurs when a system spends more time processing page faults than executing transaction. While executing a transaction, it needs those statements, and for the statements of those transactions, it needs those pages where the statements are written. If it finds those pages in the cache, then there is no page fault occurs. If it does not find, then it is a page fault and it needs that particular page to bring from the main memory to the cache. Thrashing becomes a greater threat as degree of multiprogramming of the system increases. Obviously, when a system will process multiple programs, many programs are running, degree of multiprogramming means the many programs, much more program will run, full chance of thrashing. What actually thrashing is, let's see the picture. Here see, our target is always to utilize the CPU in its ultimate utmost way. See, there is the graph of CPU utilization and the degree of multiprogramming. As the multiprogramming increases, CPU tries to execute and so on. At for some time, after some time, you will see there is, see, first it is increasing in a rapid way, then the curve bends slightly, that means it is slowly increasing the CPU utilization. After then it comes to near to parallel, this we can use the CPU utilization speed so much, and after a time, that point where the thrashing starts, that means the CPU utilization start decreasing, because here it always tries to execute all the programming and it tries to search all those page where all the programming transaction statements are written in those pages, and tries to find those pages. It will spend so many time, so that what I have written in the first line, it spends more time per page per faults rather than executing transactions. The graph in the figure shows that the degree of multiprogramming that is optimal for system performance, it is showing the optimal limit also. Utilization reaches a maximum before a swift decline as the degree of multiprogramming increases. That is the point where, say, the thrashing starts. That is declining to utilize the CPU. It starts decreasing as the multiprogramming increases, and thrashing occurs in the overextended system. This indicates that controlling the load on the system is important to avoid thrashing. Obviously, this says that we should not keep that much load, that much program, that many program to run in the system, so that the thrashing will occur. It's important to maintain a multi-programming degree. That is the number of multiple program, that is mean how many programs it will run. That's corresponding to the peak of the graph. That is the point. That is the point where I am saying it is better to stop in the first curving point, and you can stop in the thrashing point also. The selection of the replacement policy to implement virtual memory plays an important role. Here, the virtual memory really plays an important role. How it is playing an important role? Part in elimination of the potential of the thrashing. It tries to eliminate the thrashing potential. How? It tries to decrease the page faults. How? Again, in every partition, if there is a virtual memory, you will find that it will try to supply those pages to the CPU, and the multiple CPUs will get multiple cache and in every partitions will supply those pages to its cache, and it will decrease that particular virtual memory will act as supplying those pages, will keep those pages and supplying those pages to the cache, and which will help to decrease this particular thrashing. Elimination of the potential of thrashing. A policy based on the local mate will tend to limit the effect of traffic. In local mate, a transaction will replace pages from its assigned partition. Immediately it will replace pages from its assigned partition. Its needs to access memory will not affect transaction using other partitions. That is, different partitions or different dimensions are running. So one partition's transaction will not affect the other partition's transaction. We are having multiple CPUs in a particular computer. We know dual core, duo core, trio core, pentacore, and so on. It needs to access memory will not affect transaction using other partitions if other transactions have enough page frames. That every partition will have page frames, because every partition will have a different cache, and that particular virtual memory is helping to supply those pages from there to the cache in the partitions they occupy. They will continue to be processed efficiently. A replacement policy based on the global mode is more likely to cause thrashing. In the global mode, replacement policy will really occur thrashing if there is no partition, since all pages of memory are available to all transactions. That time all pages are available for all transaction. A memory intensive transaction may occupy large portion of the memory. Obviously, when a particular transaction is depending on the memory much, so that is totally is written in the memory, then it will also increase the probability of thrashing and decrease the utilization of CPU, making other transactions susceptible to page faults and resulting a system that thrashes, that will system will thrash, and the page fault will occur much more frequently. Thank you. If you want to know more, now I will discuss about the how to prevent thrashing in the next class. You may contact me. My name is Sandip Mukherjee. My contact number is 90649 79329. Thank you.